Hello, we'll be now taking up the applications of all the theorems which we had discussed in previous few sessions. The first question I think will be a very simple one to need to be taken, just a direct application of the theorem. It says this is a parallelogram which is named as A, B, C and D. These angles are marked as 3A, this has been given as 5A, this is marked as 2A. We have to find the four angles, that is angle A, angle B, angle C and angle D to be calculated. Let us first find. This is given to be parallelogram, of course. I write it here. It is given that ABCD is a parallelogram. Now in triangle ABC, I use some other color. In triangle ABC, angle C plus angle CBD plus angle BDC is 180 degree. That is the angle sum property of a triangle. So we'll substitute the values given. This is given as 5A. This is given to be CBD is given to be 3A and BCD is given to be 2A. That is equal to 180 degrees, so that makes it a 10A equals 180 degrees. So A is equal to 180 by 10, that is 18 degrees. That means angle C becomes 5A, that is 5 into 18 gives us 1590, thereby making this part, that is angle CBD, to be 3A, that is 3 into 18. Even if we don't do so, we can directly find, because if angle C is 90, angle AB also 90. Opposite angles of a parallelogram are equal. Also we know angle AB is parallel to line AB is parallel to DC, thereby making angle B plus angle C to be 180, angle on the same side, interior angles. If angle C was 90, then angle B will be also 180 minus C, that is 90, that gives you 90 as well, thereby making angle D 92. So angle A, B, C, D in this figure, they are all 90 degrees. Let's move on and take up another question. Here a figure is given. Let me draw the figure and then I write the part which is given. A, this being B, this is C and that's D. This point of intersection given to be X and this is Y. Says ABCD is a parallelogram and line segments AX CY bisect the angles A and C respectively. We have to show that AX is parallel to CY. Let us name this angle as 1, this to be given as, oh, this was given in the figure as well, huh? This is 3. As because ABCD is a parallelogram, the whole of angle C will be equal to, now because AX and CY are the bisectors, so angle A is equal to angle C, so obviously half of angle A will be equal to half of angle C. That makes angle 1 equal to angle 2, because this part which I have marked is half of angle A and this part is half of angle 2, thereby making angle 1 and angle 2 to be equal. Now it says, it is already informed that AB is parallel to DC. They are parallelogram, thereby making angle 2 and angle 3 equal as well. They are alternate interiors. Angle 1 is equal to angle 2, angle 2 is equal to angle 3. So from equation 1 and 2 we can say that angle 1 is also equal to angle 3, this one. Now if you see, and if we take like AC and AX and CY to be two lines and AB is working as a transversal, then angle 1 and angle 3 are corresponding angles. If 1 and 3 are corresponding angles, thereby making AX parallel to CY. If any two corresponding angles are equal in the given two lines under transversal, then the lines are supposed to be parallel. Therefore, AX is parallel to CY. That's what we were supposed to prove. Move on with more question. I write here, given triangle ABC, I'll draw the figure as well. Lines are drawn through A, B and C parallel respectively to the sides BC, CA and AB, forming triangle PQR. So let us draw the figure as said. There is a given triangle I draw the figure as it is given. Lines are drawn through A, B, C parallel respectively to, this is to the sides B, C, C, A, B, which forms the triangle PQR. So P, Q and R. This is the figure given. Against this question, we are asked or supposed to prove, show that BC, this one, is half of QR. To do so, we see that there are lines drawn parallel. So AQ is parallel to CB and AC is also drawn parallel to QB, thereby making this opposite sides parallel, makes this AQBC to be a parallelogram, right? So I write AQBC, opposite sides are parallel. AQBC is now a parallelogram. As because AQBC is a parallelogram, opposite sides will be equal, thereby making BC sorry, it's not parallel, it's already parallel, we had proved. So BC is equal to AQ, as well as AC is equal to BQ, right? That's one thing. Similarly, we can see that AR is parallel to BC and AB is also parallel to RC, thereby making this ARCB a parallelogram. I again draw it with some other color. What I look forward is this one, ARCB is a parallelogram. Thereby, if that is also, that's a parallelogram, that would make BC to be equal to AR. We had first seen BC to be equal to AQ. Now we see BC is equal to AR, thereby making AQ equal to AR. AQ is equal to AR. So I can write AQ is equal to AR, can also be written as half of QR. AQ is equal to AR is equal to half of QR, as because AQ is equal to BC. As because AQ is also equal to BC, we can write BC is equal to half of QR. I think this is what we were supposed to prove. BC is equal to half of QR. So we have got our answer. We have got our proof. Hope you followed it. Thank you.